Hello guys, and welcome to the fourth screencast in the Getting Good with JavaScript series. We've got a lot to cover in this screencast, so let's jump right into it. I've already got a chapter4.js file and chapter4.html file created here and ready for our use, and I've even got them open in Firebug. So let's start. The first thing we're going to talk about in this screencast is this. It's kind of hard to talk about because this is an actual concept in JavaScript that we're going to discuss right now. This, yes, that's the actual name. So this is a keyword that you can almost think of it like a variable, but it's like a dynamic variable that you can't actually control. So most of the time in your code, this is a variable that references the global object. So we've talked a bit about the global area or global variables before, but what's this global object? Let's look at it like this. Remember those parse int and parse float functions that we used at the end of the last chapter? Or remember the alert function that we used to create alert boxes in the browser? Those are global functions because we can access them from anywhere. That means they are, when we say they're global functions, what we mean is they are actually methods of the global object. Because all the objects, or basically all the functions and variables that JavaScript gives us by default, are all part of a global object. So for example, we could do this. We could say this.alert, this.parseInt, and we'll just have the string 100 in there. And now if I come here and refresh the page, you can see we get 100, and actually let's do this just so we know. We can say type of, and we get numbers, so you can see that this.parseInt is parsing the string 100 to a number, and this.alert is giving us the alert box. So suddenly we're using this to refer to an object, and using alert and parseInt as methods of that object. Normally, we wouldn't do that. Normally, you would leave those out. But what we're showing you here is that there's a global object. For example, this still works. But there's a global object that's at work here that we can't really see by default, or we don't need to see by default, but is very much there. Even variables that you create. So for example, if we say, we'll just say, if I just create a value like that, then I can alert it with this dot my variable, and that works fine. So what this shows you is that when we create normal global variables, just like creating a normal variable, we can access it via this dot my variable. So it becomes a property of the global object, just like anything else. We can think of this global object as something like this, although we can't really see it. Think of it as a global object that has many properties. One of those properties is called window, which refers to the global object itself. And then there are others here, stuff like that. And then think of this afterwards, we get this equals global. So this is kind of what we have. So what I'm trying to say here is that there's this, but then there's also window. So if I alert, I could say, and I could actually say window.alert, window.parseInt 100. And notice we get 100 just as we had before. Let's make sure parseInt is working by adding type of there, and we do get number. So both window and this refer to the same object, and actually I can alert this.window, which shows you, we get the window object, which shows you that the window and this, even though they're the same thing, they have a property that refers to themselves, which makes it kind of, it just increases the confusion. So that's the default value of this. Just in your normal code, this refers to that global, kind of that global object that all global functions and global variables are properties and methods of. However, we can change what this refers to, and there are three ways that we can do that. The first one is with the keyword new. remember when we created a new date by saying new date? Well, that's using the keyword new with the date function. And we're going to look into a bit more of this right now. So when we do that, we're actually creating an object. And we've talked about objects before. Let me tell you this about objects right now. When you keep related functionality in an appropriate object and access it via an appropriate interface, for example, we create date objects and all the date properties and methods are held within that date object, and we access it via those methods on the date object. That's a really basic description of what's called object-oriented programming. We're going to look at object-oriented programming a bit more in a couple of minutes, but object-oriented programming languages have something called a class, which is just like a blueprint for an object that you can create objects from. And although JavaScript's very object-oriented, it doesn't have classes, it has prototypes, which are real objects. So keep all that in your mind, and now let's get back to new. All that information, we're going to use it all in a minute, but come back to new. And so I said other languages have classes that they use to create new objects. In JavaScript, we just use normal functions to create new objects. However, using the new keyword in the way we did, so for example, making a normal function call and putting that new keyword in front of it, turns what would normally be a normal function call into, it treats the function a bit differently so that it becomes a constructor function. It's a function that constructs an object. So let's see how we want to do this. Let's say we want to create a truck object. So I can say function truck, and let this function take one parameter, and that will be the model of the truck. All right, so inside this function now, if truck is called with the new keyword, this refers to a new object that we can put properties on. So for example, I can say this, let's say number of tires equals 4, this dot kilometers equals 0, this dot model equals model. So this looks like a very different function from what functions we've created before. But the important thing to note here is two things. First of all, notice we aren't returning anything from this function. Second of all, notice our use of this in the function. Let's see how we would use this function, then we'll talk about the way those things work. So let's create a truck. We create it by saying new truck, very similar to the way we did date, right? And we'll give this a model name, we'll call it Hercules. I'm taking this example straight from the book. All right, so when we call this method, the new keyword in front of it, the new keyword does two things. First of all, it creates a new blank object that is referred to as this inside the constructor function. So this is the first way we change the value of this, by using the new keyword to change the value of this inside a constructor function. The second thing new does is automatically return that object at the end of this function. So notice we're not returning anything from this function, but we are assigning the returned value to a variable. So now, if I console.log my truck, you'll see we have a truck object here with three properties: the number of tires, the model, and the kilometers driven. Okay, so that's pretty basic there. Now, we could have also created this truck very simply by doing something like this. Just saying my truck, saying number of tires equals 4, kilometers equals 0, model equals Hercules, just like that. And that is really the very same object. We're going to look at why you would use the new keyword and constructor functions to create objects in a few minutes. For now, let's go on to two other methods that change the value of this inside of your JavaScript. I'm going to leave our function truck here because we're going to use it again. So remember that everything in JavaScript is an object. This is a bit of recap. Even a function is an object. Because a function is an object, it can have a property and it can have a method. There are two methods that functions have by default, and those are the methods of call and apply. So let's see how this works. We've got our truck function here, and now we're going to say, let's create an object here. We're just going to call it basic vehicle, and we're just going to say year equals 2011. So we'll give it a year for this model. Now, here's what I'm going to do. I'm going to say truck. So when I say truck, I'm referring to that method. I'm referring to this constructor function that we have up here, right? So truck dot, and I'm going to say call, then I'm going to say basic vehicle, and I'm going to say speedio. So what does this do? Let me just log basic vehicle here, and we'll talk about this. So this is the second way that we can change the value of this. It's by using the call method here on the truck function. Now this looks really, really weird. We're calling a method on a function. It takes a lot to get your head around in the first place, but it's very valuable when you do it, when you understand how it works. This is object-oriented programming. So what this does is it says we want to change, basically this is the most blatant changing of the value of this that you can do, because the call method basically says we want to change the value of this inside this function. So whenever we see the word this inside the trunk function, what do we want this to be? That whatever object we want to have the value of this becomes the first parameter of the method call. So we're saying basic vehicle, the basic vehicle object will become the object that this points to during this specific call to the truck function. After that, any parameters that we need to pass to the truck function can get passed to the call function that is being called off the truck function. And so we're passing speedio as the model of the truck. Notice we're not returning anything here. Because we're not calling truck with new, nothing will get returned. But this points out something special about objects. Objects are reference values. If you were keeping track of what was going on with our primitive values, such as numbers and strings, in our previous screencast, where we've been looking at all their methods, you'll know that when we get, well, for example, if I have, let me do this. I'm just going to comment this all out for a second so I can show you how this works here. If I have a string here, let's say the name is Bob, right? If I say console.log name dot split, we're going to split it on O. And then I console.log name. I think you'll understand, oops, if I go back to the console here, that when we split name on O, call this method, we're not actually changing the value of the variable in name. We're returning a new value. We're returning this array, but as you can see with our second call here, Bob is still, name is still Bob. The name is undefined. So if we wanted to keep that, we would have had to go like this. Name equals name split O, and then name will be kept. We have to reassign name. So when we do that kind of thing on a string, the operation does not override the variable we're calling the method on, because it's a string is a primitive value. And the way it works is a primitive value, such as a string or a number, is stored in a spot in RAM. You keep track of it with a variable, and whenever you pass that variable to a function or call a method on that variable, you copy the value to a new spot and perform the operation on the new one, and work with that so the original variable is unharmed. So when you pass it to a function, the original variable doesn't get hurt. It's the new one that becomes the parameter of the object. And so that's how we can do something like this. If I take this part out here and still have our name string. Now there are some methods, for example, the push, pop, shift, unshift methods on arrays that actually do adjust the array. But an array is an object, remember, and objects are different. What's special about an object is it's a reference value. And what this means is when we pass an object to a function or call a method on an object, we actually change the object. We're actually changing that object. There's only one object in RAM, and you're passing a reference to that object in RAM to the function. So back up here, since objects are reference values, what's going on here is we have this object here in RAM. The basic vehicle points to this object in RAM. When we pass basic vehicle here to the call method, and we say that we want this inside the truck function to equal basic vehicle, what we're saying is we want it to point to the very same object in memory. So now both basic vehicle here and this inside the function both point to the very same object. So when we say this dot num of tires equals 4, we're actually adjusting the basic vehicle object. So that's why we don't need anything to return from this function, because we're actually augmenting the basic vehicle. So down here, when I console.log basic vehicle, as you'll see here, as soon as I make sure basic vehicle is spelled correctly, if I refresh the page, you'll see that this object that started out with just year 2011 has had these 3 new properties added to it. So this is the second way we can change the value of this, by using the call method. Along with this, in the second way, is using apply. The difference between call and apply is that apply takes only 2 parameters. The first one is the basic vehicle, is the context object. Realize that this is often called the context for this function. So call takes the context, and then we pass as many parameters as necessary. Apply takes only 2 parameters. The first one is the context. The second one is an array. And this array, the items in this array will become the parameters of the method or of the function that we're calling apply on. In this case, truck only takes 1 parameter. But what we could do here is, let's do this. We can make it take number of tires as the second one here, and replace this with number of tires. And then we can add 4 in there. So now we have an array here where apply takes an array. And so now if I refresh this page, you'll see we have our same object here with year, number of tires, model, and kilometers. So both call and apply do the same thing. They take a context object and they change the context when we call truck. Now realize they're not changing it permanently or anything. They're just saying call truck just this once, and when we do, set basic vehicle as the context or as the value of this. If you have a hard time remembering which one call is and which one apply is, you can remember that the words apply and array both begin with A and end with Y. And they both even have a double consonant in them. So that's a useful hint. Okay, there's one more way to change the value of this, and that is by working, well, you'll see how to do it. I'll show you as we go along. So let's begin by making a waitress value. So here we have a waitress. Her name, we'll say, is Ashley. She's going to have a greet function. She's going to take a customer name as the greet in the greet function. And this will just, actually, first let's do this. Let's say customer equals customer or there. And we'll say, actually, let me take the punctuation off there. And she's just going to return, hi. Customer. My name is Ashley. What can I get for you? Just something like that. All right, and then that will be all. So we'll end our waitress object there. Very good. All right, so here's our waitress object, and that works fine. Let's do this. waitress.greet. We'll give this a try, and we'll have Bob go to the restaurant, and I should console.log the greeting, and we say, "Hi Bob, my name is Ashley, what can I get you?" That's great. Let's do this though. Waitress.name equals Melissa. We'll just change it to that. If I refresh the page, the waitress object has changed its name. Let's console .log the waitress object to see that that is the truth. We can see the waitress object now has a name that's Melissa. It has a greet function as well. But in the message, it's still saying my name is Ashley. So we need to fix that. So hopefully you can realize that we need to do this. We need to change Ashley here to something else. But the question is, what needs to go in there? Well, let's try something. First of all, you might think name, but that doesn't work. As you can see, my name is blank. And if you think about it, that makes sense, because normally you would expect name to be name. When you call a name like that, that's supposed to be a variable, not a property here. To get a property, we use waitress.name, right? Let's do that. Waitress.name. Okay, that's working. But what if we do this? So waitress.name works, because then we set waitress.name to Melissa. Let's do this. Instead of saying that, if we do that, if we take away the setting waitress.name to Melissa, it switches back to Ashley, so that's working. But let's do this. Let's set doppelganger to waitress. So basically, remember, doppelganger is now pointing to waitress. Now, since waitress is an object, both doppelganger and waitress are pointing to the same object in memory. We didn't copy it. We're pointing to the same object. And then let's set waitress to null. So now we're basically saying waitress, the waitress variable is no longer pointing to the that object. So now doppelganger is the only pointer to that variable. So now we're going to have to use doppelganger in our console here, because waitress is null. So let's see what we get here. Whoa, we're getting an error here. It's taking us straight to this console here. Now, you don't have to worry about what all this means right now, but the point is basically that it's not working. If I try and refresh the page, we're taken to this script console that we're not discussing in this book. That's a bit beyond us right now. But here you see we get this message, waitress is null. But it's trying to find, so it's going to waitress here and saying waitress is null. We can't get the name property on a null. Null doesn't have a property. So the point here is that waitress.name works until waitress no longer points to this object. And we can never be sure that our objects will always be referred to by the same variable. What we want is where this object could be referred to by any variable, and it will always work. Hopefully you've guessed by now that what we want to put in there is this. This is the third way that we can change the value of this. When we're inside of an object literal this way, the value of this is the object itself. So now we can do what we've done here. This refers to this object in memory, not necessarily labeled by waitress. So now when we switch the label from waitress to doppelganger and try and greet Bob, if we refresh the page here, if I have to clear that first to get rid of the error, you can see that we have no problem with the message. And then here, if I change doppelganger got name equals Melissa, you can see that the object's name changes and the value in the message changes as well. So that's great. So that's an introduction to this. And now that we kind of understand how this works, we're going to get into a little bit of object-oriented JavaScript right now. What I'm going to show you with object-oriented JavaScript is just the tip of the iceberg in what you can discuss. manipulating objects in JavaScript. If you're interested in pursuing this topic more, I have a screencast series on object-oriented JavaScript on the Tuts Plus Marketplace, and that'll give you a very advanced view on object-oriented programming in JavaScript, and you can check that out at a link in the book. So let's create another constructor function here to see, because object-oriented JavaScript is all about creating objects, of course. So let's say we have a object or a constructor function here that creates computers. All right, so we have a simple little structure here. We're going to give the computer a name, we're going to say how much RAM it has, and we're going to say how much hard drive space it has. Very simple. All right, so now we can create a new object by doing something like this. So let's say var laptop equals new computer equals my new laptop. We can say it has, let's say it has 4 gigabytes of RAM and 1024 megabytes of hard drive space. I know that's not much, but just for our example, that's what we're doing here. And then we've created a new object, and we say console.log laptop. And there's our object right there. All right, let's say we want to add some things to this. For example, so let's say you want to add a method that allows us to add a file, and you want an array of files that are stored on this computer. So we might say this dot files equals an empty array to start with, and then we could say this dot store file is going to be a function that takes a file name and a file size. See, isn't this creative? And then we can say this dot files, and we'll just make this simple. This dot files dot push file name, and say this dot space minus equals file size. We won't do any checks right now to make sure we're not overrunning the amount of file size. We'll just assume this is an example. So this seems pretty innocent, but this is a problem. We don't create functions inside of a constructor function like this. We should not ever add a function this way. And the reason this is because, remember, when we use the new keyword here, we're creating a new object. Right? Laptop here is a new object. As you can see here, if I refresh the page, we now have added files as a blank empty array and store file as a function there. The problem with this is that every time we create a new computer, we're going to create a new store file function. And once you get using objects like this, you can get objects that are going to have a lot of functions or big functions on them. And you don't need every function, and you don't need every object, every copy of every, like for example, in our case, we don't need every computer object that we have ever created in a given session to have their own version of the store file function, mainly because the store file function is exactly the same code for every single one. You know, name, RAM, space, files, those kind of things are actually going to change from time to time. I mean, from object to object, right? But the functions, they're going to be the very same in all of the objects. Especially because we can use this to refer to the objects inside of them, which means that this is going to refer to whichever object is using the function, right? So what we need a way to do is say, this is the store file function. Every computer object should have access to this function. And when a computer object is using the store file function, this inside the store file function refers to that computer object. This is what we can do with prototypes. I mentioned earlier that JavaScript uses prototypal inheritance, and this is what it is. So watch, I'm going to remove this. I'm just going to move it out here. And what I'm going to do is change, instead of saying this here, whoops, I'm going to say computer.prototype. What we've done here is pretty interesting. We've said computer.prototype.store file. So basically we've said on the prototype for the computer object, and we'll discuss exactly what this means in a moment. The computer function has a property that is named prototype. Prototype is an object and it has a property named store file. We're adding this store file property and saying that it is this function. So the way this works is that we can run this store file function from any computer object. I told you earlier that the new keyword is doing two things. It's actually doing three things. First of all, it's making this refer to a brand new object that it's created. Second, it's returning that value, the object that this is. Thirdly, it's not creating a blank object. Like, it's not creating an object with no properties at all when we do this. It's creating an object that inherits from the computer.prototype object. This is prototypal inheritance. What it means is, for example, we have this laptop object here. I'm going to do something here. I'm going to say laptop.store file. We can say family.jpg, and we'll just say it is a 30 megabyte file, just like that. And then let's console.log laptop down here. If I refresh this page here, we can see that the files array has one file in it, family.jpg, and space has been we've subtracted. We started with 1024 megabytes. We've subtracted 30 megabytes down to 994 megabytes. So how did laptop get a store file function? Well, when we said new computer, the laptop object was created. It inherited everything that the computer.prototype object has. And then we added these specifically to it. So here's the way it works. We say laptop.store file. Laptop looks at all the objects. The laptop object looks at all the properties and methods that it has. This is the list of them right here, that we added them in the computer constructor function. It says, I don't have any store file method. So it goes to its prototype object, which is computer.prototype. It says, do you have a method named store file? In this case, yes, it does. And so it gets access to that method and can use it. So it's made one step up the prototype chain. If computer.prototype did not have it, it would ask the prototype of the computer.prototype object. In that case, it's object.prototype, which is the prototype for every object in JavaScript. So I want to make sure you really understand what's going on here. When you use the new keyword, you're creating a new object that is assigned to this, which is what you assign the properties to inside the computer function. That object inherits all the properties and methods that you have on the computer.prototype object, and then it has access to them. So that's why it's called prototypal inheritance. So let's look at one more example just to cement this down. I'm going to show you this in a different way. So function.product, function product, we're going to create a product function, constructor function here. And we'll say if there was a name passed to this function, this dot name equals that name, and that's all we'll say in there. Then let's say, we're going to say product.prototype. So on the prototype object, we're going to have a name, a default name that's going to be to be announced. You're going to see how this works in a second. And then we're going to say product.prototype.rating equals 3. So now let's say var iPod equals new, well, first let's just say new product. And then let's say console.log iPod. So let me run this here. If I refresh this page, come back here to the console tab, we have a product. It has two values, name equals to be announced, rating equals 3. Oh, notice it has this proto thing here. This proto is, it's a Firefox specific thing, but it just shows you the prototype object for it. This, if you look at the prototype object, you can see that name and rating are coming directly from that prototype object. But the point here is that name and rating, when it outputs name and rating, it's outputting them as if the values that are on the prototype that have been inherited as if they were values of the iPod object itself. They aren't really, but they're made to look like it. So let's pass this iPod a name. So we could say iPod Shuffle as the name. Now, if I refresh this, console tab again, you can see that we now have iPod Shuffle as the name. Notice on the prototype, the name is still to be announced. But if I was to ask the iPod object, what is your name? What is its name? It would say iPod Shuffle, which is true because we've assigned it iPod Shuffle. The iPod object has a name property. It does not have a rating property, so it uses the prototype rating property as its rating property until we define a rating property, a rating for it, and we say iPod.rating equals 2. Now we can see that the rating here equals 2. The prototype rating still is 3, but it has its own rating now, and that's 2. All right, so let's talk about a few of the methods that objects have by default. We're going to start with the hasOwnProperty method because it's very relevant, first of all, to what we're doing right now, and also relevant to the for in loop that we discussed back at the beginning, or at the end of chapter 2. Remember how at the end of chapter 2 we talked about the for in loop where we looped over the properties of an object? Let's do that right now with our iPod object. So I'm going to delete these things. We have iPod. I'm going to say for var prop in iPod. Let's say console.log prop plus colon, just so we can see what they are. iPod prop. So notice we have name is iPod Shuffle and rating is 3. So it looks like we have two properties on this object, but the fact is we don't. We know, because we've just seen, that the rating is actually on the prototype. And so that's where the hasOwnProperty method comes in handy. Let's do iPod.hasOwnProperty. This is one of those default methods that objects have by default, and we're just going to pass it prop. Actually, what I've done here is I've meant to put an if statement around it. So notice what we've done here. If iPod.hasOwnProperty prop. So the hasOwnProperty method on every object, what you can do is you hand it a property name, and if the object has its own property with that name, it will return true. If it does not, it will return false. So what we're saying here is if the property that we're looking at actually belongs to this object, then continue. In this case, we're going to write it to the console. If it does not have it, well then how would it say it does? Because it's on the prototype. So if it's not there, then we're going to skip writing it. So now, instead of getting both name and rating, if we refresh the page, you'll see that we just get name. This is something we should always do because often when you're looping through properties on an object, you don't want all the properties. You just want the ones that are on the object itself. Sometimes you may find you want ones that are not on the object, but that's going to be rare. So it's a good idea to always use the hasOwnProperty. It does make your for loops a bit messier because you have to include this extra if statement in there. But I think you'll find that you won't be accidentally tripping up on extra properties that you weren't expecting if you use the hasOwnProperty in an if statement like that, just to double check your properties. Let's look at another method that comes built into many properties. So let's say we have a simple object here that's just O with name. And basically it's toString. The toString property basically returns the object in a string format. If you ever try to, notice here I'm saying alert o.toString, and we're going to get object. Even if I left off toString, we would get object as well, because alert takes a string as its parameter because it's printing out text to a window. And the toString method is often called whenever a string is required and it has to convert the object to a string. As you just saw, object is pretty useless. So what we can do is rewrite the toString method to give us something more useful. So for example, here we could say we want toString we could say return this.name. Can't forget my comma up there. And now if I alert O, whoops, I have to reverse that curly brace there. Now if I alert O, notice we get Andrew alerted. toString is called by default, but even if I call toString, we get Andrew anyway. So you can use that object as a kind of reminder. If you see that, maybe it's time for me to write a custom toString method. Sometimes you'll need it, sometimes you won't. Another interesting method is the value of method. So let's create an account object here. Let's say I am the holder of this account, and my balance is $100. And let's say value of. Now the value of this is a primitive value that represents your object. It's not quite the same as toString, but very similar. It's kind of complicated to say when the JavaScript engine uses toString and when it uses value of. I have a link to a forum thread in the book that will give you more context on this if you want to give it a try, if you want to try and understand it. But it's actually pretty complicated. So what I'm going to put in here is just return balance. This way, balance is the primitive value that is returned when we try to use this object with primitive values. So for example, I might say account minus 10. If I refresh this page, you can see we get 90. If I didn't have this value of function, we would probably get nan because it's expecting it to be a number, but it's getting an object. However, if I say that the value of this the value of this object is the balance property, then we could subtract $10 from the account. It doesn't actually subtract $10 from it, as you know, because the minus operator, it's not actually changing the account object, but it's giving us a sensible result. So those are just a couple of the object properties that you might want to, or you might find yourself using now and again. Let's move on to a very important feature in JavaScript, which is closure. So if you're familiar with other programming languages, you may have heard of private variables. A private variable is basically an object that's accessible to the methods of an object, but it isn't accessible to anything outside of the object. And because JavaScript doesn't have real classes to create objects, it doesn't really have private variables, but we can use closure to make this work. So before we begin, remember the two important points about JavaScript that contribute to closure. The first one is that everything, even a function, is an object, and this means that a function can return a function. The other thing is remember that the anonymous functions that run themselves that we talked about earlier, they run once and run right away. So we're going to use both of these ideas to create private variables, or basically the ability to hide parts of JavaScript from other parts of JavaScript. So let's look at something you should already know here. Let's say we have a secret number here, and the secret number is going to be 42. Let's create a function called reveal secret that's going to take a password, And if the password is please, then we're going to return the secret number, and then we're going to add 1 to the secret number. Remember the postfix increment operator. The way that works is that it's going to return the secret number, and then it's going to add 1 to the secret number. So every time we call reveal secret, secret number will go up by 1, and we're never going to get the same secret number. And then I can say return 0 here at the bottom. This is just kind of a shorthand. I don't have to put else here. You know, I could, but the point is that if password is not please, it's just going to skip to the end of this. So I don't have to put the else statement primarily because if password is true, it will return in here and we'll never get to the second return statement. So this is just kind of a cool shorthand way of doing it. All right, so isn't this great? We have this little reveal secret method or function. The only problem is there's nothing secret about the number, right? We want the number to be incremented each time, and we want it to be kept a secret. But right now there's nothing secret about it because I can just say secret number. Actually, I want to change that to secret number like that. And I could get to it without a problem. We have to figure out how we're going to make this a secret. Let's do this. I'm going to change the way this works here. So, in fact, I'm going to have to get rid of that too. So we're going to have that reveal secret method. But here's what we're going to do. We're going to assign, instead of just saying this is a normal function, we're going to assign this to one of our self-invoking anonymous functions. This function gets run immediately, and whatever is returned from this function will get assigned to reveal secret. Now remember, we can't get to variables that that are made inside of a function because of scope, right? So if I create my secret number in here, we can't get to it because we're inside of this function. We can't get to it from outside this function. So already we can see that this number is a secret. So now from this function, I'm going to return another function. And I'm just going to return the function that we had written before, right? So I'm going to return if the password equals please, whoops, then return secret number, increment the number by 1, otherwise return 0. What's actually going on here? Think about this for a second. This function here gets run right away, and its return value is assigned to the variable reveal secret. Its return value is this function here. So this function gets returned to reveal secret. So now I can call reveal secret out here, and I can pass in please. And let's do this. Let's alert this. If I do that, we get 42. Let me do this a couple of times. I get 42, 43, 44, and 45. But I can't get to secret number. What's going on here? The trick is that even after this function has returned, and this entire self-invoking anonymous function has finished running, the function that gets returned can still access the secret number. Even though this code has, it still has that link, even though the code that set this all up is finished running and all that we're left with is this function, we still have this link back into this function that this function got passed out of. That is closure, an inner function that has access to the scope of its parent function, even after the parent function has been returned. This way, we can see that the secret number, we have set it only once, it gets incremented properly each time, and it's protected because no one can get to it except if they have our password. So this is, what I've shown you here is similar to the module pattern. The module pattern is to basically set up you can have private variables and methods inside. So you basically do all your setup code in here, right? So you can set up your code for a module, which is basically just an advanced object. Then here you could return an object that had the public methods and public variables that you'd want people to be able to access. These public methods and public properties would have access to your setup code, even though this has already returned. So the idea here is that the guts of our code are not exposed. Only the parts that need to be exposed are. You're probably understanding the how of closure, but you might not get why we want to do this. You write the code, you should know not to hurt anything, right? Well, two things. It's easy, you'll find, to forget how you want things to work or how things are supposed to work. And you'll find that writing your code defensively like this allows you to protect yourself from even your own mistakes. The other thing is that often you won't be the only one reading or writing to using your code. There'll be other people who may be using code that you've published on a project you're working together on, or maybe it's code that you've published on GitHub or something like that. If you look back at our reveal function code as we had it here a minute ago, you'll see that I might note that secret number can't be changed. So why do I have to wrap it up like this? But another developer might not know that, or I might forget that if I come back to the project after a long time. By writing it like this, I can be sure that it's not going to accidentally get broken. Defensive coding is a really smart idea and something that you'll find is one of your best practices. Don't always expect that you're going to do the best you can do. You're going to accidentally make mistakes, so plan for that. Also, don't expect that everyone's always going to do what's nice when it comes to using your code. You don't want to give them the option to accidentally get in there. If they're just loading your library onto a page, you don't want them to accidentally be able to overwrite secret number if they have a variable with the same name, right? So protecting your variable like this is a smart idea. So let's move on to errors in JavaScript. There are basically two types of errors. First of all, there are syntax errors and typos, which are problems you make while coding. And then there are other errors, something you can't control. For example, a missing feature in the JavaScript engine that you expected to be there, or an error in the user's input, or something like that. Other errors the JavaScript engine can't deal with, and it will throw the error. Yes, that's the technical term. It's called throwing an error. And we can throw our own errors too. So let's talk about this briefly. Here's the error protection syntax. We have the word try, followed by a block, and then we have catch, followed by a block. So the way this works is any code that you suspect may throw an error, you put inside the try block. And then we have catch here. In parentheses here, I have the letter E. This is just and we could call this whatever we want. This is going to be the error object that gets caught. So this is where we catch the error object. So if the code that is in the try block here throws an error, and we'll look at how that would work in a minute, the catch block will catch the error object that gets thrown, because JavaScript will give you an error object that gives you some information about the error. Depending on the browser you're using, you're going to get different information. Basically, everyone gives you the name of the error and the message. Others will include other things. For example, Firefox will include the file name and the line number. Chrome will give you a stack trace, different things like that. But the main ones that you want to be concerned with for now are the name and the message properties. So let's look at how this would work. Let's go back to our coffee example that we had before. Let's create a function that we're going to call make coffee. And we're going to take a size, right? And let's create a sizes array here. So we will create, we'll just say small, medium, and large. Those are the sizes of coffee we offer. Let's create another variable here that's just called coffee. So if sizes dot index of size whoops. So we're using the index of property on an array to see if we have the size that was passed in the array. So remember, we're going to have -1, so what we have to do there is say if it's less than 0. So if it's less than 0, that'll return false, which means it's not in sizes. If it is in sizes, we're going to continue on. But if it is not in sizes, meaning if it's less than 0, then what we're going to do here is we're going to throw a new error. So we can create an error. Similarly, we could just create a blank an error object literally, but we can use the new error constructor function like this, and we can just pass in a name. We don't offer that size, right? And then otherwise, we could set coffee equal to size equals size, and added, we could just say sugar and milk or something like that, just to make this example pretty simple. Right, and then we would return coffee. But the point of this is that if the size is not one of the sizes we offer, we throw a new error. So we would know that this function was going to throw an error. There are certain cases in JavaScript that are really too advanced for you to understand right now. Things like evaluating JSON when pulling it from the server. Really, as you get into more advanced JavaScript, you'll learn, as you learn these different techniques, where browsers might throw errors and where to use a try and catch statement. We're creating a case here where we know an error will be thrown. So what we'll say here is make coffee, and we're going to say extra large. Well, first, before we do that, we should try to just, let's delete this, and let's see what happens when we just call the make coffee function just like that, with extra large. If we refresh this, you'll see we get an error in the console here that says we don't offer that size. Now, so we know that this will throw an error, so let's wrap this in a try clause, or in a try statement. We have a catch statement here. We're just going to call the error message, the error object e. And in here, let's just, in this case, we'll just console.log e.message. And so we just console log the message, we don't offer that size. Now, what we're doing here isn't anything too groundbreaking for dealing with the error, but once you're working in this field more and you understand what specific activities in JavaScript can cause an error, you'll understand how to use the catch clause to recover from that error. So that's what you're going to be doing. So let's move on to talking about testing our JavaScript code. You can't have too much of testing. And there are two types of testing. There are two main types of testing. First is unit testing, which means testing each little bit of functionality as you write it. You might even want to practice test-driven development, which is the idea of writing your tests first so that you have an idea of how you feel your code should work, and then writing the code to match the tests. The other type of testing is performance testing, where you're making sure the code you write is as fast as possible. This means we're talking about running time here, not the time it took you to write it. We want the code to be efficient in the browser. So let's take a look at these two types of testing. So the first one is unit testing. The idea of unit testing is that you write tests, run them and watch the tests fail, and then you write your code, and then you run the test again and make sure they pass, and then you clean the code and basically repeat that for each feature. So that's the process of test-driven development. So let's kind of go through that here. But the first thing we're going to need is a little test library, because when we're writing tests, we need some code to actually write the test part, right? And so there are two types of tests we want. Number one is an assertion test, which basically says, is this true? And the other one is an equals test, which says, are these two things equal? Here on the desktop, I've got this test.js file that I'm going to add in here. I'm going to add test.js. You don't have to worry about exactly what's in it. It's a bit beyond our level right now for writing this kind of code. But the point is that we have this little library, and basically you'll see down here we have two objects. We're returning this object here. Well, first of all, notice that we're using the, if you look at this is in the downloadable code that you have, and a bit later on you can look at it and you'll be able to understand more what it's doing. But the point is, down here at the bottom, we're returning an object that has assert and equals functions, and we'll see how these work in a minute here. But the point, the reason it's a bit beyond what we're used to right now is because it does some work with HTML that we're not going to be covering that until the next chapter. So after the next chapter, you can go and actually look at the code of that little test framework that I wrote, and you'll see how it works. I've also just included a little bit of CSS up here, which we're not going to discuss at all, but it's pretty simple, and you can look at that too in the example code. So let's begin by, let's say we want to create a business object. So we're going to start by writing the most simple test possible, which is going to be test.assert, and we're going to assert that the business constructor function exists. And we're going to say we're testing for the existence of the business function, right? So it's that simple. We're making a call to the test.assert, and I think test is in all uppercase. So if I come back over here and refresh the page, you'll notice that we're actually, let me see, this should be giving us an error here. So we're not even getting a failed test. Well, we are getting a failed test, but we're saying business is not defined, so it can't even find business to run the test. So this test is failing. So let's do this. Let's create the function business. So we're just going to create a blank function. And now we can come back here, rerun the page, and you can see that our first test has passed. So we have a business function. So what you just saw there was a really quick round of unit testing. We wrote a test, we ran the test failed, we wrote just enough code to pass the test, and now we have a passing test. So now we're going to add our next feature. Let's say var b equals a new business. We're going to pass it the name of my business, and we'll give it the year 2000. So we're going to have those, we're going to want those properties in the business object. So after we test that business exists, we're going to do test equal, and we're going to test b.name should equal my business. And then we're going to say business name is my business. So now we haven't used the equal function yet. Let's see how this works. Basically, it takes 3 parameters. The first 2 should be equal for the test to pass. The third one is a message, just as the second one is a message in the assert function above it. So let's come over here and run it. And now we're getting a failing test. So business name is my business. That test fails. All right. So now we have to write something to get this test to pass. So let's say we say this dot name equals, well, first of all, we want to take a name here as a parameter, and we do that. So now we're assigning the parameter name to the property name on the object. If I refresh this now, we have a passing test again. All right, let's do another one. Test dot equal b dot year of founding should equal 2000, and we'll say in our message here, business year of founding is 2000. Our test is failing. I think you know what we need to do to fix this. We'll say year of founding. This dot year of founding equals year of founding. Refresh that, and now the test passes. Excellent. All right, so let's add another test here. Test.assert. We want to assert that b.getAge is a function. So we'll say business has getAge function. And let's add another one right away. We'll just say test assert. Actually, we'll say test equal type of b.getAge should be function. So let's actually clarify what we're doing here. We're going to say b has getAge, right? And then we want to say here that business getAge is a function. So notice the granularity of these tests. The first thing, when we say we want to assert that b has a getAge, then we're going to assert that we're going to make sure that the type of getAge is function. So these two tests fail right now. So notice what I could do is I could say this dot getAge equals 0. And see, 0 fails because it's a false value, but I could say, I could just set it to true. And now we have the first test to pass, but the second one fails because even though it has getAge is not a function. So what we have to do is add this to the prototype, right? Because we don't add functions to the actual objects. So business.prototype dot, what do we call it? GetAge is going to be a function. And what this function is going to do is we're going to return, let's put this in new date dot get full year minus this dot year of founding. So basically we're getting the current year in there, and I'm just wrapping this in parentheses to make it clear what's going on, minus the year of founding. So now if I refresh this, that's passing. Very good. So we'll stop there, but this is a basic example of how test-driven development works. And if you want to learn more about test-driven development in JavaScript, you can check out Test-Driven JavaScript Development by Christian Johansson. I hope I'm pronouncing his name right. You can read an excerpt of the book over on NetTuts, and there's a link to that in the book. That was unit testing. But let's talk about performance testing, because there are often several ways to write one thing in JavaScript. But just because there are several ways to write the same thing in JavaScript doesn't mean those ways are all equal. So you'll want to use the one that performs the best. So what we're going to do right now is we're going to test two ways of doing something, and we're going to see which is best. So when we're testing something small, the kind of quick and dirty way to do it is to store the current time, run the test, store the new current time, and subtract the two times to see how long it took. Now it's going to run, you'll find that no matter what you're testing, the test is always going to be different in different browsers. But you can get a good idea of how they're going to work. So let's implement a simple test here. We're going to have two arrays, and we want to add all the items from the second array to the first array. And we're going to find that there are three ways to do this. The first one is to loop over the second array and use array.push to push each item one by one into the second array. The second is to use the arrays concat method, which we didn't mention earlier, but what we can do is return a new array with the items in two arrays, and we can just reassign the value, reassign the variable that had the first array in it. And the third thing we could do is use the arrays push method, which can take as many parameters as we want to push in, but because we have the second item as an array and not as a set of parameters, we could use the apply method on push to turn that into a list of parameters. So we'll see how this works. Let's go over this. So at the very top here, I'm going to start by assigning a bunch of, or creating a bunch of variables. We're going to have D1, D2, D3, D4, D5, and D6. Then we want to have array1, which is going to equal, we'll just put 1 and 2 items in there for now. Then we'll have array2, which is just going to be empty for now. Then we're going to have I, which will equal 0, and we'll just have a length variable as well. So we'll set all these things up. Oops, we got to make sure it's a comma there. Set up all our variables. All right. So now we need to fill up that second array. So let's say we already have I set to 0. So while I is less than, we'll say 100,000, I plus plus, and array 2, I equals I. So why 100,000? Well, the point is that JavaScript engines nowadays are so fast that unless we make a really big test, or unless we do a very simple task many, many, many times, we're not going to get very much in the way of results at all. So that's what I'm going to do there. And then I'm going to set I back to 0 again, and I'm going to set length to equal array2.length. All right. So now that we've set up our testing environment, we're going to start with test 1. So let's say we're going to say d1 equals new date dot get time. Remember, that'll give us milliseconds since the Unix epoch. Now let's run the first test. So we're going to say, well, I is less than length, I plus plus, whoops, array1 dot push array2 I. So one by one, we're going to push each item from array2 into array1. And we'll see how long that takes. And the way we can do that is by doing new date dot get time. So notice we're getting the time before the test and the time after the test. And then we're going to subtract d2 minus d1, and we'll see how long the test actually took. So we'll do that in a minute here, but let's go on and do the second test first. So we're going to have d3 equals new date dot get time. So I'm actually going to have to reset array1 first. We'll just set it to what we had before, just a small array with 2 items in it. Now let's say array1 equals array1.concat array2, and new date get time. So there we go. That's our second method, our second test. And then why don't I just put some headings here? We'll just say test 1. Down here we'll say test 2. And then here we'll say test 3. And what's test 3 going to be? Well, first let's reset array1 one more time to 1 and 2. And the way this works is we're going to say array.prototype.push array1 array2. This might look a bit confusing at first. Oh, I forgot the time. So let's add those, and then I'll explain what we're doing there. Whoops. Okay, so what we're doing here is we're saying array.prototype.push. Remember, even the built-in values have prototypes. All the functions that we can use in arrays, all the methods of array objects can be found in array.prototype. So we have array.prototype.push, passing in array1 and array2, just like that. So array1 becomes the context for .push. Array2 becomes the parameters, and I've forgotten to put apply in here. So we're applying all the items in array2 as parameters. So basically this would be the same thing as doing this. Array1.push and passing all those parameters in one by one like that, because we can put in as many parameters to push as we want, and it'll push them all in at the end. But the point is, we have this as array2 as an array, and so we can't, if we put an array in, it would just push that array in as a single value, which is not what we want to do. So we use apply which turns array2 into a list of parameters, which is just what we want. And this whole part, array.prototype.push, we have to use because we can't call array directly on array1. So there are our 3 tests. So now to see which one is faster, we can do console.log, and we'll say looping and pushing, and we'll have d2 minus d1. All right, console.log, we'll say arrays concat is going to be d4 minus d3. Then we can say push via apply, and that is going to be d6 minus d5. And that's it. So now if we run this here, we're going to see in the console, hopefully this should work. So notice that looping and pushing took 6 milliseconds, arrays concat took 3 milliseconds, and push via apply took 2 milliseconds. Notice that even if I run this several times, we're going to get slightly differing results. And if I ran this in different browsers, we would get different results as well. So what you could actually do is type this into jsbin.com. jsbin.com is a really neat little, it's almost like a paste bin for JavaScript. So what you could do is paste all that JavaScript in there, copy all this code. I'm going to paste it in here. And now if I say render, dismiss, now see we don't have a console here. Or can I pop up a console? Let's see if it'll work. If I do code, now render. And you can see how long it would take to do it in Firefox here. And then I could save this. Now I get this URL. If I go to the URL directly, now I could copy this URL and go paste in any other browser, open up the console that those browsers have, and I can get the same thing. Of course, I could alert these out too if I wanted. So that's how you can do quick and dirty performance testing just like that. Now, if you want to do some real, some more advanced performance testing, you can go to jsperf.com. jsperf.com is a performance playground, as they say here. You just fill in your thing here, your name and details here. And then you can use your test, you can put in your test case, describe it. Here's where you write your preparation HTML, your preparation JavaScript. Then you write your test for code 1, code 2. You can add as many code snippets as you want, test 3, test 4. You add all those tests. Then you save the test case. When you save the test case, you can then, you get a URL that you can run it in multiple browsers. You can give other people the URL, and it'll actually save their tests. So if I go here to popular tests, notice here we have jQuery, well here's a, let me see, what do we have, anything you would, selecting the first, let's see what this is. So basically, notice what we have here is, here's the preparation HTML, here's the output of the preparation code, and here are a bunch of different ways that they can do what they're trying to do here. They're using jQuery here, which we don't discuss in this book. It's a JavaScript library if you're not familiar with it. And they're trying to select just the first item here, a bunch of different ways. So see, I could choose right here to run these tests, and it's going to run them multiple times. It's going to figure out which one, it's going to tell me which one works fastest in my browser in a second here. But notice this down here, we have browser scope. All these different browsers have come to this and run the test, and we can see here what the results are for these browsers. This is a bit beyond where you are right now, but if you want to try this out, have fun with it, feel free to go ahead and do that. You can see here that this tells me that the fastest way to do it was this way here. We're not going to discuss this much further because you're not familiar with jQuery, but I think you get the point that in performance testing, you can get pretty fancy with it and check out all, look at, wow, this is a huge list of browsers. And then of course, JSPerf also allows you to make revisions, or you could add a comment, that kind of thing. So it's pretty neat. So if you need to do some serious performance testing, you might want to play with it. Look at a couple of other of the tests here to get an idea of how to use it. All right, so let's move from the topic of testing your JavaScript to organizing your JavaScript. There's more than just writing actual code when it comes to JavaScript. For example, how many files should you put your JavaScript in? As we've seen, you put your JavaScript in a file, in its own file called whatever.js, and then you can link it up here in the script tags like this. But how many script tags should you have on a page at once? Well, it's wise to separate your code into multiple files to make it easier to work with. You can separate functionality, and it makes it much more manageable when you're actually writing the code. However, once you actually write the code and are serving it on a website, you're going to find that when you split it into several files, there's actually an additional cost paid by your users. That's because when they download the JavaScript files, every file has a bit of overhead. For example, the HTTP headers that comes with the file. And so because of this, it's better to put all your code into one file to minimize that overhead. So the best way to do this would be to write your code in separate files, if necessary, to make it a lot easier to just develop. And then there are programs like build scripts that can help you automate the process of concatenating those files together. Showing you actual scripts like this is probably beyond your skill level at this point. I wrote a tutorial for this that's been published on NetTuts, and I have a link to that in the book. And you can check that out if you're ready for this. But basically what it is, it's a script that it takes all the JavaScript files you've written for a specific project, and it concatenates them all into one. So basically strings it all into one JavaScript file, and then it minimizes the JavaScript. So what does minimize mean? Well, basically, when the user has to download, when they go to your web page, they download the JavaScript so it can run. The browser does it for them. And every byte that they have to download adds a bit to their download time. So to improve the download time, you want to take out all the bytes that aren't necessary. And all these bytes are the white space. For example, the spaces that you have in places where it's not specifically necessary, any tabs that you use to keep your JavaScript lined up, to make it easier to read, line breaks, all that kind of thing. Shorter variable names would make it quicker because every letter is a byte, right? So all those extra bytes are there to make our job in coding easier, but it actually makes it more work for the browser to download the file. So minimizing your JavaScript is using command line utilities. I had a link up to a bunch of them in the book, for example, JSmin, YUI compressor, Google Closure. And what they do is they strip out all the extra stuff in your code that you don't need to have there. So for example, let's, if I was just going to, let me clean up a whole bunch of this here. And if we were just going to look at this for loop, for example, whoops. What it would do is it would take out all these extra spaces that are not necessary. I would concatenate this all into one line, just like that. Now I've used the letter I as my variable here, so it's as short as it could be. If I'd use a longer variable there, it would change that variable name. It might even do something like this. It might do 1e to the power of 5 to make that number even shorter, just like that. So we've taken what was a 3-line for loop with nice spacing, and we've just shrunk it down into as little space as possible. So that is optimizing your code. And there are several, you never have to do that yourself, as I just did now. There are several tools that I've linked to in the book that you can do, that you can use. I've also linked 2 articles by JavaScript performance expert Nicholas Zakis on JavaScript minification, and I really recommend you use those tools. So now, let's also talk about global variables. You remember me mentioning earlier that global variables are a bad idea, and they really are. The reason is, as I mentioned earlier, that it's not defensive coding. But more than that, think of this. Once you become familiar and comfortable with using JavaScript, you'll find that it's more than just your code that's on your page. You'll use libraries and helper methods and codes from other developers as well. And if your site is advertising on it, those advertisers will want to insert their ads via JavaScript as well. So if all that code relies on global variables, there's a very good chance that some of those global variables will have the same name as others. And because the code is coming from different developers, they're not going to know that. If you have two variables with the same name, well, you can't have two variables with the same name. One of them is going to overwrite the other one. Somebody's script stops working, and it becomes very hard to debug. So as we discussed earlier, this is a great place to use those self-invoking anonymous functions that we talked about earlier. Just like this, you can put all your JavaScript inside a anonymous function like this, and all of your variables cannot be touched from the outside. They're safely tucked away inside. If you're writing a library or something that needs access from the outside, you can use one global variable, and that's all you would need to by assigning a return value like this. If you do something like this, and then you're going to return an object with just the stuff that needs to be accessible from the outside. You can use the module pattern, which we talked about earlier. One thing I do is give my global variables all uppercase letters. I do this for two reasons. First of all, it makes it clear to me when I'm reading my code that that is a global variable. I know that all my global variables are all uppercase letters, and it's easy to see them, and I know I can keep them to a minimum. The second reason is this isn't really a common convention, at least not too widely done yet, and so it reduces my chance of having a variable overwritten. Alright, so one more thing before we close this chapter out. Here's a secret that I've been keeping from you all the way along. JavaScript actually has some bad parts. There are several terrible features that you really shouldn't ever use. And I haven't mentioned them anywhere in this book so that you have a relatively pure understanding of JavaScript at this point. But eventually you're going to need to know about the bad parts. You'll find them as you're going around on the web, and I really recommend that you buy Douglas Crockford's book, JavaScript: The Good Parts. It's going to do more than just teach you what's naughty and what's nice about JavaScript. It's going to take your understanding of JavaScript to an entirely new level. You will not regret that purchase. And once you've read that book, or even before you've read that book, you might want to check out his tool JSLint, which you can get at jslint.com. Basically, you just paste your code in, click run, and it's going to tell you what bad practices you're using in your code. You can also check which bad practices you want to see down at the bottom. Now, I'll tell you this much. Douglas Crockford is probably the most vocal JavaScript developer who talks about these bad parts. However, there are other very well-respected JavaScript developers who don't exactly see eye to eye with him on everything that he calls a bad part. So basically, as you grow as a JavaScript developer, you're going to have to decide for yourself what's good and what's bad. Well, that brings us to the end of chapter 4 in Getting Good with JavaScript. We've only got one chapter left, and in that chapter, we're going to learn about how we can use JavaScript to interact with our HTML. See you there.